Okay, welcome to our second day of e-learning. We're going to go over the review today. You need to be making corrections on this review. You should have it completed. And then after you finish, you need to submit it to me through Canvas. So to start off with, similar polygons. We're going to say two polygons have corresponding angles that are equal and corresponding sides that have the same ratio. The geometric mean. Geometric mean is the number b such that a over b equals b over c, and b is equal to the square root of ac. Ratio, a comparison of two quantities by division. A proportion is two equal ratios. The altitude of a triangle is a segment going from a vertex to the perpendicular to the line that contains the opposite side. Don't forget this, to the line that contains the opposite side. Altitude of a quadrilateral with parallel bases. The altitude is the segment perpendicular to the lines that contain those bases. And a polygonal region is the union of a polygon and its interior. The areas formulas should be for rectangle, base times altitude, or base times height. For a square would be the side squared. For a parallelogram is base times altitude. For a triangle is going to be 1/2 base times altitude. For a trapezoid it will be 1/2 the altitude times base 1 plus base 2. And finally for kite it will be 1/2 diagonal 1 times diagonal 2. When solving the proportions here, we will just be doing cross multiplying. So here we start out with 52x is going to be equal to 52, and we get x equals 1. For the next formula, we're going to have 40x equals 16 times 2x plus 1, which will give us 40x equals 32x plus 16. Take away the 32x, we get 8x equals 16, so that x equals 2. For geometric mean, don't make this difficult, it's just multiplying and taking the square root. So in this case, we will have the square root of 60, which we can simplify to 2 times 2 times 3 times 5. For every pair, we can take one out, leave what's inside. For 8 times 5, same idea. If you want, you can start it out as just 8 times 5. 8 is 2 times 2 times 2 times 5. 2 times 2 is 4, 4 times 2 is 8. Take out a 2, and it leaves you with 10 on the inside. Okay, so for determining similar, you've got a few different ways to do that. You've got angle, angle, which you'll see a lot of. You've got side, 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 and you have side, angle, side. All of those are for similar. In this first one, you've got parallel lines. Remember parallel lines, always think of Theorem 19 or the corollaries. In this case, we have A, E, B, C, and D. Since they're parallel, this angle is equal to this angle. This angle is equal to this angle. We have a pair of angles in both, so we would say this is by angle, angle similarity. When we go to do our write-up, make sure that the correspondence is correct. So we're going to start at A, E, B. A corresponds to D. So I'll say that is similar to D, E, C. Again, doesn't matter the order as long as corresponding parts line up with each other. A to D, E to E, B to C. For the next one, parallel lines again. Think theorem 19. That means this is going to correspond to this. Those are corresponding angles. And these are corresponding angles. You could use n equals n as reflexive, but you don't need it since you only need two angles. So again, we'll say angle-angle similarity is the reason. Then do your lineup, which will be n to p to o, similar to n to m to l. Next one. You should notice here that you have 50, 25, 40, 20. You've got E, I, H, G, and F. So I need to think about which ones it could be. I don't have anything about parallel, so I'm not going to be able to use angle-angle here. I do have this shared angle here, H. And so what I'm going to do is I'm going to check the sides. I've got H, I, G, and 50 and 40. The big triangle is E, F, H, which is shared. This side will be 75. This side will be 60. So I need to check bigger side to bigger side, since I already have the angles. I'll do 50 over 75 and see if that equals 40 over 60. They're both equal to 2/3. So we have side angle side similarity. And to line up our parts, we're going to take IHG, make that similar to EHF. The last one, we don't have anything about angles, all we have is sides. So I'm going to start by setting this up as, is 8 over 12 the same as 20 over 30, is the same as 24 over 36. Small side to small side, medium side to medium side, large side to large side. In this case again, we have that they're all going to be equal to 2/3, so they are similar. Similar by side, side, side. And then we need to be careful about how we write our similarity statement. So we're going to start with, let's say, A to B to C. A to B is the largest side, and it goes to the smallest side, so we would be O to P to N. So it's either going to be angle, 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 angle side, angle side, or side, side, side. (17), you need to think a little bit about something else. You can't solve this by just setting up a proportion. You first have to find what y is. And in this case, you're going to get 3 squared plus y squared equals 7 squared, and you will get y is equal to the square root of 40, which is 2 square root 10. I use the Pythagorean theorem to find y first. Once I have that, then I can set up 4.5 over 3 equals 5x over 2 square root of 10. Cross multiply, I get 15x equals 9 square root of 10. Divide by 15. X equals 3 square root 10 over 5. You could also make these as decimals, and that would work as well. For number 18, we have a small triangle, sides 5 and x. We have a big triangle with sides 12 and 60. 5 over 12 equals x over 60. This side is 12 because it's the entire side of that triangle. Cross multiply, and I'll get x equals 25. Moving on, we're using the side splitter or corollary. Remember, it almost makes it look like a proportion if you just extend this. You've got 6, 2, 9, and x. So 6 over 2 equals 9 over x. When you cross multiply, you get 6x equals 18, or x equals 3. Remember, if you do have questions, you can email me or call me during those times that we have, which would be 9 to 11. For the next one, we have x over 12 equals x plus 1 over 15. 15x equals 12x plus 12. Don't forget to distribute. Divide over, 3x equals 12, so that x equals 4. (21) and 22, you'll want to use the corollary because you have the whole side. So you would have 3 over 7, the whole side, equals 6 over the whole side, which will give you 3x equals 42. X would be equal to 14. So I did 3 over the whole side equals corresponding part over the whole side. 22 is going to be similar, except you've got to find that missing piece, which is here is 6, this is 10, it was 16, take away 10 gives you 6. Corresponding side is x, and long side is 8. 6 over 16 equals x over 8. Cross multiply, you get x equals 3. (23) is the proof of Theorem 40, so you can't use Theorem 40, obviously. We did do this one in our notes. Let's go through it again. Start with our given, obviously, is that we have the altitude and the base. I'm going to start by drawing MT, which is postulate 1. From there, I'm going to look at the whole figure and say that the area of the whole thing, MATI, would be equal to the area of those two triangles, MAT, plus the area of triangle IMT, postulate 8, which is the area postulate. Then I look at the individual triangles. Area of triangle MAT is going to be 1/2 the base times the corresponding height, and MH. And the area of triangle IMT is equal to 1/2 the other base, and again the same height. This is theorem 39. 38 is for right triangles. 39 is for any triangle. At this point, because I want to be using IT and not MA, and this is a parallelogram, MA equals IT by theorem 25. Replace that in this one. By substitution. And then you can finish up by adding, plugging those two formulas in for this. just substitution. And I'll combine in this step and simplify it down to our final answer. Oh, keep one step. And there you go. I would know this theorem. This is one thing that would be likely to come up on a test. Next page, again, we're thinking either angle-angle or side-angle-side or side-side-side, mostly focused on angle-angle. In this next proof, we have a pair of parallel lines. This is point R, this is S, this is T, although the drawing doesn't look like the one we have, but it'll work. Excuse me. And this is F. So these are parallel, which means these angles are corresponding. Whenever we think of parallel, we think of corresponding. I'm not going to label these as R and S just because it could be mistaken here which one it would be. So I'll do SRM is equal to angle TSN by theorem 19. If you wanted to number them as 1 and 2, that would be fine as well. We've got these are perpendicular. I will go ahead and label those 3 and 4. Angle 3 and angle 4 are right. Definition of perpendicular, which means 3 and 4 are equal. Corollary definition of right. And now I have an angle and an angle, so I can say the triangles are now similar by angle-angle similarity, which is exactly what I wanted to show. So again, remember, thinking parallel lines, you're always going to want to think about theorem 19 or one of the corollaries. For 25, some of you may have been confused by the A-C-G. That just means those points are collinear. Let's start with these are parallel. If those are parallel, those angles are corresponding. So I'm going to start after my given. Angle 1 is equal to angle 2, theorem 19. Now you may say, well, wait a second, we're looking for segments being multiplied together. That should make you think about proportions. So we're going to cross multiply, and to do proportions, we need to make sure that our triangles are similar again. So I'm going to connect this to this and this to this. These again are parallel, which means those angles are also equal by theorem 19. This means that triangle ABC is similar to CDG by angle-angle similarity. Now be careful about corresponding parts. I want AB and AC. So I'm going to do AB over CD is equal to AC over CG. Definition of similar. And then if I have that, I can cross multiply and I get AB times CG equals CD times AC. By multiplication. The last proof here Again, we're looking at proving that these are similar triangles. Think about angle, angle. We have a trapezoid. We know in a trapezoid that the bases are parallel. So start with your given. Make your statement AD is parallel to BC. By definition, bases of a trapezoid. Once I have that, then these angles are equal, and these angles are equal. By corollary 1, theorem 19. I'm looking at parallel sides. Those form equal alternate interior angles. You could have used vertical angles if you wanted to, but there's really no reason. And at this point, but if you did, it's fine. At this point, we have the triangles are similar. By angle, angle similarity. For 27, you should have first theorem 38. You're proving theorem 39 here. For step 2, you're going to have postulate 8. Anytime you're adding areas together, you get the whole area. For C, you should have subtraction. For D, you should have substitution and simplify, or substitution and factoring. E, because you're measuring the length of a segment, you're going to use theorem 1. And for F, you're going to have substitution again. 28, the bases are 9 and 12, so you're going to do 1/2 times 3 times 9 plus 12, you get 31.5. For the next one, it's just base times height, you have 11.25. Next one, your altitude is 4, your base is 15, 60. And finally, 1/2 base times altitude, so it's 8.75. So again, that's 31.5, 11.25, 60, 8.75. 29, do not make this difficult. Ratio of perimeters is equal to the ratio of the sides, 5 to 1. Areas just squared. On the next one, always go first to second. A is going to be 4 to 8, or 1 to 2. B will just be squared, 1 to 4. For 31, you have a ratio of the areas is 144 over 36. So that means you take the square root of it. You get 12 over 6, which is 2 over 1. And that is both for the perimeter and the ratio of the sides. On the next page, you have 8 to 6, which will give you 4 to 3. Now again, that's the ratio of the sides. So the areas ratio is going to be that squared. Once you have the ratio of the areas is 16 to 9, set that up as 16 to 9 equals x over the area of the one you know, 12. It's the smaller one, and x will be approximately 21.3. On the next one, set up corresponding triangles again. You're going to have 3 to 30 equals 2 to tree. When you cross multiply, you get t equals 20. Now, this brings up an interesting argument. If we have a tree plus a tree plus a tree, we would have a sum of 9 because it's tree plus tree plus tree. If a dirt storm comes and makes all the trees dirty, We now have 99 because we have dirty tree plus dirty tree plus dirty tree, 99. And finally, let's say a little forest creature runs along and leaves a little dropping at the bottom of each one. Now we have it's equal to 100 because it's dirty tree and a turd plus dirty tree and a turd plus dirty tree and a turd. And yes, I put this question on the worksheet just for that joke. Moving along, I can hear the groans. 34, we have vertical angles, we have right angles, so we have angle-angle similarity. Make sure the correspondence, let's do A to B to Z. It's going to be similar to G to H to Z. A corresponds to G, B, H, Z, Z. For 35, we would have to have a proportion of the sides, which would mean we would have to have 12 over 20 equal to 21 over 35. Let's see if we reduce this. This will be 7 will be 3 to 5. 4 goes in here, 3 to 5. Again, remember I'm using the full length of the side, so I would have side angle side similarity. And I would have triangle CQT, triangle CMP. (36), you check the sides. In this case, you're going to have that they all simplify to 2/3. So similar by side, side, side. And then I'm going to look at my correspondence. I'm going to start with, let's say, y to x to z. Y to x would be r to p to q. Once again, if you did zxy, then it would be qpr. If you did xzy, pqr. Last one, you have vertical angles that are the same. So you need to check small side to small side, big side to big side. So you need to check if 12 over 16 equals 15 over 24. That is not true. Those do not cross multiply. Not similar. Okay, so tomorrow we will grade assignment from 11.1 and we'll do notes on 11.2. And I hope you have a good rest of your day. If you have any questions, remember to contact me.